All right, in our previous video, we took a look at redox reactions, and we said these are the reactions where you transfer electrons. Today, what I want to do is take a look at two new types of reactions. The first is called a combination reaction. And if you notice, a combination reaction can either be a redox reaction or a non-redox reaction. And then the second type is a decomposition reaction. And again, this can be a non-redox reaction or a redox reaction. So let's define these, and we'll start out with decomposition first, and then we'll go to composition or combination. So decomposition is really straightforward. It happens when a single substance breaks up into two or more simpler substances. Simpler substances. There we go. Sorry, it takes me a little bit to write these down sometimes. And I think it's pretty easy to represent a decomposition reaction just symbolically. So we're going to start out with one thing. I'm just going to make this reactant A. And reactant A is going to decompose into two simple things. It could be more than two, but in this case, I'll just do two. And I'll say it's going to break up into two new things. I'll call those B and C. All right, so this would be an example of a decomposition reaction. But let's go even further, and let's take a look at some example reactions rather than just a pretend symbolic one. Okay, so the first one I want to do is pretty straightforward. So in this reaction, we're going to have calcium carbonate, which is CaCO3, and this is a solid. This is really just chalk, right? And you can decompose this under high temperatures to make calcium oxide. Again, calcium oxide's a solid. And when you do this, you generate CO2 gas. This is a common industrial reaction. But my next question for you is, we know this is decomposition. We're starting out with one thing, and we're going to two new things. But is this a redox reaction? So let's check. Over here, I'd say that calcium is always going to be calcium 2+ because it's in group 2A. Same thing over here, it's calcium 2+. The only time it's not calcium 2+ is when the calcium is elemental, meaning by itself. But in this case, we're going to treat it as an ion because it's with other atoms. Okay, then we'll go over and we'll do oxygen. Oxygen, we said, is always oxygen 2-, unless it's in a peroxide. That's the one exception where it's 1-. But in this case, it's just going to be 2-. Same thing over here, oxygen 2-, and it looks like this one over here would also be oxygen 2-. So I can tell immediately that nothing has changed between these oxygens from our reactant side to our product side. The same is true for the calcium. Nothing's changed. It's still calcium 2+. But let's check this last outlier. Okay, and this last one is carbon. So let's think about it. What should the charge be for this carbon and calcium carbonate? Well, we said that the calcium is going to be +2, so that's one part. And then we'd say, well, we've got 3 oxygens, which are each 2 negatives. So I'd say 3 times -2. That's going to be my oxygen side. And then I'm just going to call this value X. That's going to be the charge for carbon here. Sorry, let me keep the color coding. And we know that the sum of everything should be equal to 0, right? Meaning that the oxidation number for calcium plus the sum of the oxidation numbers for oxygen plus the oxidation number for carbon should all add up to 0. Okay, so if we go ahead and we solve for this, X in this case is going to be equal to +4, right? So you can go ahead and do that quickly on your scratch paper, or you can just trust me on that. But this is going to be carbon 4+ if we treat it as ionic. So make sure that you're capable of inferring the oxidation number of anything on that interior side of the periodic table, not the far edges. Okay, so we've identified carbon. I'm just going to erase this for clarity. And we said that the carbon and calcium carbonate is going to be an oxidation number of carbon 4+. Well, let's check over here. And we can do the same thing, right? We'll say that X plus the oxidation number sum for oxygen, which is -2, and we've got 2 of them, has to add up to be 0. So in this case, it looks like X is also going to be +4. So I'd say that carbon is 4+. So in this case, it looks like every single atom is the same oxidation number on the reactant side as the product side. So this is a non-redox decomposition. All right, there are other examples where they're redox, but you have to go through and check, kind of like we've done here. All right, now let's try a combination reaction. And these are quite obviously going to be the opposite, right? So we're going to combine two things. It's in the name. So it occurs when 2 or more substances form a single product. So if we think about this, we could say, well, we could have 2 substances in this case. We could have more, but I'm just doing 2 here. They're going to combine and form one single product. So it would look something like this. Let's do the same thing though. I want to do an example reaction. And I want us to determine whether or not this example reaction is an example of a non-redox combination or a redox combination. All right, so for this one, I'm going to do H2 plus O2. And let's put the states in here. I've got H2 gas plus O2 gas. And this is going to form water, which is a liquid. Like I said in the previous video, this is one of my favorite reactions. And we also need to balance it. So I've got 2 hydrogens, so that looks good. I've got 2 oxygens. I only have 1 oxygen here, so I'm going to multiply this by 2. And then I'm going to double check everything over again. I've got 2 hydrogens, 4 hydrogens. That means I should probably put a 2 in front of here. Now it looks like I've got 4 hydrogens on the left, 4 hydrogens on the right. Everything looks good. I've got 2 oxygens on my reactant side and 2 oxygens on my product side. So that looks good. All right, but now let's check the oxidation numbers. So over here, this is elemental. It's by itself. So this is going to be H0. And over here, this is hydrogen that's now going to be treated as ionic. So it's going to be H+. We can immediately tell, without even looking at the oxygen, that electrons have been moved around, right? In this case, the hydrogen looks like it lost an electron, which means it was oxidized. Okay, so a combination reaction in this case could be a redox reaction. But let's double check oxygen. Because this is oxygen by itself, I'll call it oxygen 0. And because this is oxygen in a molecule, I'm going to call this oxygen 2 negative. So it looks like it gained an electron, which means it was reduced. Okay, so in this case, it's pretty clear that it's going to be a redox reaction. So up here, we said that some can be non-redox, but this is a redox combination reaction. All right, I hope that helps. Like I said, there's not really great shortcuts. I still prefer to go through and kind of map things out, kind of like I did here. However, if you find any shortcuts that work, you can definitely use them on any quizzes or exams. All right, good luck studying.